All right, guys, let's take a look at some rotations. When we talked about translations, we were talking about sliding things. We were talking about reflections. We were flipping something about a line. A rotation, now we're looking at spinning an object. All right, this is still a rigid transformation, which means whatever we spin is going to be the same object that we started out with. But let's make sure we understand what kind of information would I need to know before I wanted to rotate something. All right. Yeah, we'd want to know about our object, but number one, we would want to know how much. How much are we going to rotate? All right. With rotations, we're talking about degrees. How many degrees would you want to rotate? We would also need to know which direction we would want to rotate. Now, the rotational directions are not left and right. They are clockwise and counterclockwise. So clockwise would be a direction that goes with an analog clock, and counterclockwise would be going the other direction. All right. And actually, you would need to know one more idea. You need to know, what are you going to rotate around? What is the center of rotation? Most of what we're going to be doing in this class would be around the origin, but it becomes an important idea. All right. So we're trying to just look at a basic rotational scenario. I always like to mess with this object. I don't know why I use letter E, but to me, it helps frame this in a decent light. One other thing, when we're talking about directions, this is a tricky little idea. If we do not mention the direction, you need to assume counterclockwise. All right. This is not a strange scenario. This is actually related to a more geometric / calculus type of idea. We're going to rotate counterclockwise in most assumed mathematics. So let's try and take a look. And here would be some notations. All right. So let's say, and the way we would notate, I would use a capital letter R because the lowercase r is already used for reflections. But if I wanted to rotate, and then we would use a subset to say how many degrees we would like to rotate. I didn't mention the direction, so we are assuming counterclockwise. All right. The nice thing about rotations is if I take an example of the scenario like this, I can physically rotate. Here's against the clock, 90 degrees. A 90-degree counterclockwise rotation should end up here, looking like this. All right. And then try in your mind, see if you can figure out what would a rotation from the original object of 180 degrees look like. See if you can see it in your mind, maybe possibly write it down real quick. If you really want to challenge yourself, this would be a good time to pause the video and see what you got. Otherwise, here comes the answer. Again, if I wanted to physically rotate, there's 90, and here goes another 90. So I should end up in quadrant 3 down here, and my E is facing the other direction after that rotation. Let's try one more time. Let's try a rotation of 270 degrees. Again, if we want to physically see what's happening, we got 90 here. We got 180 here, and now we're into 270 down in quadrant 4. All right. So this would just be some basic type of rotations. Understand if I wanted to go 90 degrees clockwise, that's the same as 270 in the other direction. If I wanted to rotate 360 degrees, I'd end up right where I started. So technically, I could put another one, rotation 360 degrees. Make sure you don't use that on your project because that means our object's going nowhere, and we actually want our objects to go some places. All right. So let's look at this maybe a little bit more in depth. All right. So let's actually take a point. Let's look at the point 1, 2, 3, 4, 5, 1, 2. This is my point 5, 2. We want to try and see what happens when we rotate 90 degrees. Again, I didn't mention the direction, so we're assuming counterclockwise. All right. So that point that was at 5, 2, if we take that object and we rotate it 90 degrees, I'd want you to see what are the coordinates of that new point. All right, now if we reset our look at this, now the point is at -2 to the left 2 and up 5. So after a 90 degree rotation, my point is actually here. The image of P would now be at -2, 5. So look what happened, because we want to be able to write a rule. What happened to that point after a 90 degree rotation? Well, look, the numbers switched, and the 2, which was the second number, changed its sign. So what's going to happen is we're going to switch the numbers, and that second number, which is now first, changed its sign. That's how we perform a 90 degree rotation. -y, x. Let's see if we can take a look what happens at 180 degree rotation. Well, that point that was at 5, 2, after a 180 degree rotation, it's now at -5, -2. Well, the numbers didn't switch, they just changed signs. So if you want to do a 180 degree rotation, all you got to do is keep those numbers right where they are, but change their signs. All right. And our last one, 270 degrees counterclockwise. There's 90. There's 180. And now we have 270. This point is now at 2, -5. So again, going from here, our original point, to this new one, the numbers switched. But the first number ended up changing, so this is y -x. These are going to be very important. I would highly recommend writing down this rule and keeping it close, if not memorizing this. All right? And this is all assumed to be rotating around the origin. rotating around the origin. Okay? So make sure you practice this on your homework because it's not always that easy. Good luck.